Welcome to the introductory presentation for ITIntelligence at Scale. My name is Matthew Saunders, and with my partner, Amy Morina, we were the sole developers, testers, and document creators for this project. Our product owner and mentor is Jason Detbarn. While there are many IT monitoring solutions in the market today, many of these solutions still lack key functionality that IT administrators like to see. Some of these functionalities include a robust solution for alerting on Mac computers, IT monitoring solutions that can scale for an organization, being able to visualize the data in a meaningful way from multiple sources, and being able to collect software usage across an organization. The Gantt chart below shows the activities that were completed and the timeline of when they were completed. For a more detailed view, the Gantt chart can be found in the project documentation. The user stories that we were able to implement during the semester include collecting the user login and logout activity, user application usage, available updates for devices, and user hardware information. It also includes a collector caching mechanism, a server mechanism to retrieve data from the collectors, MongoDB to store factor data, application data, software updates, user login and logout activity. User stories implemented in this semester also included displaying the data that was collected. These displays show the user login and logout activity, available software updates, application usage, factor reports, socket usage, CPU and memory usage, and non-volatile event timelines. The UML sequence diagrams of the implemented user stories are shown here briefly. For more detailed information, visit the project documentation. The system is composed of four main units. The first is the agent, which resides on the client machines within an organization and collects the data from the client systems. The second is a server, which both receives data from the agents on the client systems and serves data requests to the dashboard controller. The third is a dashboard controller, which sends requests to the server for information and hands any information it receives to be rendered in the view. The last unit is a web dashboard view, which displays the information to the IT administrator. The architectural patterns used within this project are the model view controller architecture and the caching mechanism within the agent. The system deployment is broken down into four components: the factor tool and the collector, which both reside on the client systems within an organization, the web server, and the Mongo database. The hardware requirements for the system are a Linux-based server, and the software requirements include Django, Python, Java, AngularJS, JavaScript, MongoDB, and Factor. The system does not use any persistent data within the current version. Security and privacy is limited to running the system using an SSL certificate. The class diagram shows the four main units of our system and how they relate to each other. The ADG collector is a collector that resides on the client systems. The dashboard is a view that the IT administrator uses to view the data that is collected by the collectors. The server is used to process data requests both by the dashboard and to receive data sent by the collectors, and MongoDB is used to store the data that the server processes. Two main design patterns were used within our project. The first is a factory method, which is used in the collector to spawn the different collector objects. The second is the front controller, which is used in the Python server to provide a centralized entry point for handling all requests. The main control object for our system is our server. The state chart below shows the states for a single thread running in our multi-threaded server. The server starts out in a ready state. Upon receiving a request, it will then process a request and either send a response or store and retrieve data from the database before sending the response and then returning to the ready state. The select application algorithm is used within the software metering display to show software usage for a specific application. The steps in this algorithm are as follows. The application name is first selected from a list by the user. The selection is sent from the view to the controller, to the service, and then to the data request factory within AngularJS framework. The data request factory then makes a REST web service call to the Django server. The Django server takes this call and then processes the request, querying the Mongo database for records of the selected application. Records are then returned to the data request factory, which are then sent from the factory to the service to the controller. The controller parses the records to the correct format to be displayed. The data is then passed from the controller to the view, and the view updates the display. Here is a Sunny test case for selecting the application. The purpose is to ensure that the application graph refreshes automatically and reflects the selected application's activity for the application selected by the user. For setup, the user navigates to the Dashboard 2 tab and then expands the software metering module. For input, the user will select an application from a drop-down menu. The output is that the graph automatically refreshes with the activity for that application. The following is a rainy day test case for selecting an application. The purpose is to ensure that the graph refreshes automatically, reflecting the selected application's activity. The setup, input, and expected output are the same as the sunny day test case. However, the actual output differs because the graph does not reflect the requested changes. This is due to a JSON parsing error that occurred when trying to parse the data. The automated test scripts used in this project are cron job. A cron job is installed on all client machines to automatically run the collectors and send or store the data depending on the caching mechanism. This allows us to run our test cases without having to manually seed the database. Now for a short demo. Here is the first of 2 dashboard displays developed for the ITIntelligence at Scale application. The top bar allows the IT administrator to pick the organization and tenant to show its data for. Here is a factor report display, available memory display, CPU and memory utilization graph, non-volatile event timeline, and network socket data. Here is the second dashboard of the ITIntelligence at Scale application. This is software metering, which allows you to select up to the top 10 applications being used by a system. Allows you to select the time period and show just system or all. Software updates show updates within the organization's tree. And login history. This tab is used to inject factor data within the database for testing and demonstration purposes. Thank you for watching the introductory video to ITIntelligence at Scale.